Good afternoon, everyone. Thank you for joining us. My name is Marissa Waterman. I'm the Marketing Director here at the Academy. Here with us today, we have 4 of our 40 Under 40 Recognition Program recipients. They will each give a brief talk on their topic. We'll cover 4 topics in under an hour, and we'll have time for questions and answers in between each presentation. During the presentation, you'll be able to submit a question by clicking on the Q&A icon on the bottom of your screen. Also joining us today is our Executive Director, Dr. Daniel Uther. Dr. Uther will serve as the moderator today. Before we get started, Dr. Uther would like to say a few words. Hi, Dan. How are you?
Hi, Marissa. Hello from sunny Florida. Hi, everybody. Welcome to the Academy's PechaKucha event. This is a second PechaKucha event that we've done, and I'm so excited that we have 4 fantastic speakers today. Marissa, I'm sure you guys can probably see a little beach in the background, a little sun. I just want to speak to a couple of things about why I'm shooting this with this lovely background and why we're doing PechaKuchas. So one of the things that we've heard from the profession is that we would like to see the Academy be a place where everyone can belong. Early career, more seasoned professionals, later in their career, people from different technical backgrounds. We've heard that people like to be a member of the Academy because they're interested in board certification, because they want to show that they're the best of the best. They're also interested in fellowship, getting to know other people, having a place where they can belong and engage and know and grow. And so that's what the PechaKucha event is about. And that's why I've got this background going. I'm actually on vacation. I peeled a couple of hours out to be here to do this webinar event. And I want to speak to how the Academy can be inclusive, how it can be a place where people can belong, whether you peel a little bit of time off of vacation or whether you need to set some boundaries and have some work life. We're here to be able to work with people wherever they're at, where they're at in their stage of the career. And so PechaKucha, what we're doing today is an event that celebrates in people and passion and creative thought. The word PechaKucha comes from Japanese language. It's this idea of chit chat. What this translates to is a presentation that is 20 slides, and each slide is only up for 20 seconds. So what that means is that somebody's giving an entire talk only in 6 minutes and 40 seconds. That's really intense. And so we've got Lee and Dillon and Nirupam and Stephanie here with us, and we're going to really put them through their paces to give us a quick talk. But one of the neat things we get to do is break these up into kind of these little vignettes. So we're going to present each presentation, and there's an opportunity to do Q&A at the tab down at the bottom. And from that Q&A, I'll do a little bit of moderated discussion, ask a couple of questions at the end of each of the presentations, and then we'll move on to the next one. So welcome to the American Academy of Environmental Engineers and Scientists PechaKucha event. First of all, thank you to our patrons who make this possible. And let me jump in and explain that we've got 4 speakers: Lee Blaney, Dillon Hoffmann, Nirupam Aich, and Stephanie Bollard. We're going to start with Lee's presentation. Lee Blaney is a professor of chemical and biochemical and environmental engineering at the University of Maryland, Baltimore County. Lee's presentation is entitled Contaminants of Emerging Concern in the Environment, Unintended Consequences, New Chemicals of Concern, and Understudied Sources. The brief abstract is that thousands of contaminants of emerging concern enter the environment every day. This presentation highlights prominent and unintended consequences of these contaminants on public and ecological health. It identifies recently reported chemicals of concern, and it emphasizes the importance of expanding sampling locations to evaluate alternative sources. Dr. Blaney, the stage is yours.
All right, thanks so much for the introduction, Dan, and to all the organizers for putting this together. I think it's going to be a fun event here. And as Dan said, really today I'm going to be talking about contaminants of emerging concern, and this relates to all of the chemicals that we use every day. You can see here, just in the last few years, we've added 85 million unique substances. This includes, some of the classes of chemicals that you see on the left-hand side here: anti-inflammatories, soaps and shampoos, pharmaceuticals. You can see the other ones on the right-hand side. This is a photo. I'm kind of weird. Whenever I go to CVS, Rite Aid, the grocery store, I look at all the products, I turn them around, I take photos of the active ingredients, just so I know what's in some of the substances that we use. Now, ultimately, those substances go down the drain, they get into the environment, from wastewater treatment plants, agriculture, other sources. And one of the big questions with these chemicals is, since they've been so carefully designed to have biological kind of considerations in our body, what do they do with the environment? One good example of an unintended consequence is diclofenac. This is an anti-inflammatory used to treat cattle. In India and Pakistan, when cattle died, the vultures would eat the carcass. And it turns out that diclofenac is actually super toxic to vultures. Populations decreased, by over 97% just in a few years. Another class of chemicals that we're concerned with are endocrine disrupting chemicals, especially estrogenic hormones, like 17-alpha-ethinyl-estradiol. This is the active ingredient in the birth control drug. And the plot here is basically showing when you introduce very low levels of birth control drugs into lakes, fish populations can crash. One more here is the UV filters or sunscreen chemicals. These have been of increasing concern in the last few years due to potential toxicity in corals. Some of these chemicals have actually been banned from being sold in certain states due to these concerns, which are really critical, for biodiversity, economics, as well as tourism and fisheries. And then finally, it took us 5 or 6 slides, but of course, PFAS is going to be present today. You're going to hear more from the other speakers too. We know there's thousands of different PFAS. They're in a lot of different products, and there's upcoming regulations that are going to be very challenging to meet. So all of these different contaminants of emerging concern, they can get into the environment from different sources. This is a figure from the EPA that was put together in the early 2000s that I really love. Like, it was very forward thinking. They highlighted a lot of interesting sources here, some of which have been well studied, some of which have been a little bit understudied, and that's one thing that I want to try to emphasize as we move forward here. Maybe some of the more well-studied sources are wastewater treatment plants and agriculture. Some of the less well-studied sources I want to talk about are kind of present in the left-hand side of this figure. You see septic tanks, you see sewage lines, and these can end up leaking, and being important sources of emerging contaminants into the environment. Hey, Marissa, it looks like we're stuck on this slide.
Hold on one second.
Okay, so following from there, I would want to say one thing that I'm kind of excited about is, where I live. So I live in Baltimore. We're right on the Chesapeake Bay. This is really an interesting test bed for us. The western side of the bay, we have a lot of urban areas, suburban areas. Wastewater, septic systems are big sources. On the eastern side of the bay, we have a lot of animal agriculture, and this can also be sources of CECs like antibiotics and hormones into the bay. One thing that we've been interested in doing over the last 5 or 6 years is trying to understand those sources. Typically, we start with indicator chemical, sucralose. Maybe you put sucralose in your coffee. This is a synthetic compound, it's an artificial sweetener, and it serves as a great tracer for wastewater because it doesn't occur naturally. So we kind of looked at our sucralose concentrations around the bay. We were actually surprised. We thought wastewater treatment plants were going to be like kind of the major source correlating to sucralose concentrations. But what we actually found is when we sampled more diverse areas across the bay, septic system density was actually better correlated to sucralose levels. And septic systems aren't something that many environmental engineers think about all the time, but 20% of Americans are on septics. The data on this slide is showing that we found a lot of different CECs at high frequencies in septic wastewater and also at very high concentrations. So we're the weird people. We're going around knocking on doors, asking people, hey, can we sample your septic system? And thankfully, people were pretty open to that. Coming back out into the Chesapeake Bay here, here I'm plotting antibiotic concentrations. We were measuring 50 or 60 different antibiotics, so this is kind of the sum. Generally, they were present at low concentrations, except for a couple of areas where we started reaching like around 100 nanograms per liter. And this is where you can start selecting for antibiotic resistant bacteria. And so that's a huge public health concern, something that we're interested in trying to limit in Chesapeake Bay region. And then finally, I'll just mention, we weren't just sampling water, we were also sampling sediment and oysters from the bay. The UV filters are a little bit more hydrophobic. They partition well into oyster tissue. And so here's concentrations of one of the sunscreen chemicals that we're interested in. So the findings that septic systems were really important for CEC levels in the bay actually kind of motivated us to come back up, into urban areas. So here we're sampling in Baltimore in urban streams that don't receive wastewater effluent, but are around a lot of sewer infrastructure. And so we are worried that sewer overflows or leaks could introduce emerging contaminants into some of these streams. The columns that you see in the map here, those are all different CECs, kind of showing that we're seeing high concentrations and a diversity of chemicals in these urban streams, again, that don't receive wastewater effluent, but as you can see in the photo, the sewer infrastructure is right next to the streams. It basically runs along the streams. So any leaks or overflows can introduce these chemicals into the environment, pretty high concentrations. And actually, if we come back to septic, so this is a little bit further up in these watersheds, all of the dots in this map are septic systems. And we actually found that CEC levels correspond to septic system density. And so this was kind of critical for us because septic systems, in these more rural areas, thinking about wastewater leaks being important sources of CECs, these are ideas that haven't been explored so much. We usually kind of go to the more expected sources. I'll also just say in these urban streams, the CECs get into the water. We wanted to look at similar biomonitors, but we don't have oysters in these streams, so we use crayfish. And sure enough, we found that Baltimore crayfish are on birth control and they're using sunscreen. Finally, I just need to thank my group. They're all shown here. They're a great bunch. They work really hard. They're very positive and supportive of each other. And I get the pleasure of sharing out all of their results. So thank you very much and be happy to take any questions.
Lee, thanks so much. I love that. So you found crayfish that are on birth control and using sunscreen. Fantastic. I love that. Actually, there were some questions that came in, but I want to just kind of, hit you with kind of 3 questions so you can kind of get your mind around. We can talk through them a little bit. One is indicator compounds, right? So sucralose, fate and transport, similar to all the compounds, or are we going to get ourselves in this problem similar to using E. coli to tell us that we had feces, right? So indicators are good, but there's also some concerns with them. So if we can address that. Second, is there ever—
Can I take that one first so I don't forget?
No, and I'll come back to them, but just this gets your mind around them. So
okay.
Second, when are we ever going to be done with this problem? It's a little bit of Alice in Wonderland moving through the looking glass, right? Like there's always a new compound that we're worried about. So does this ever end, or is it? And then third is TSCA, right? So how does TSCA help us to not get these things in the environment in the first place so that maybe we answer the Alice in Wonderland question because we just do pollution prevention or good stuff up front and don't get stuff out there. So first question, indicators, sucralose. Are we getting ourselves in a similar problem like we are with E. coli for source tracking and that kind of stuff? What are your thoughts?
Yeah, I got it. Good question. So we like using sucralose, and a lot of people like using sucralose because it's fairly persistent. It doesn't degrade or break down very easily, and it also transports pretty well, so it doesn't kind of partition to sediment. And so if we're kind of looking at maybe like a worst case scenario, these chemicals are getting into the environment, they're not degrading, they're transporting downstream. Sucralose is a great indicator for that, but you're absolutely right. Other emerging contaminants have very different chemistries. That's one of the reasons why, we kind of measure a suite of around 100 compounds right now. Some of the UV filters and estrogenic hormones, they're much more hydrophobic. They prefer to partition, into sediment and tissue. And so one thing that we've been thinking about actually is using different components of dissolved organic matter as indicators for these different classes of emerging contaminants. But it's very critical to think about the actual chemistry, of each individual contaminant. Maybe that's kind of the heart of your question, because we can't treat them all the same. And so sucralose is not going to be a good indicator for some of the UV filters. And if we go in thinking that it is, we're going to have problems, trying to kind of back all of that out to understand what's happening.
Perfect. And then maybe just a quick one, and we'll just keep it really quick, right? But this whole idea, there's always an emerging compound, right? I mean, it's like there's going to be a new thing. We're going to research it, right? But how about the pollution prevention, the TSCA, the let's keep the stuff out? Thoughts on that?
Well, actually, I'd like to go to your second question because I think it's a very good one. You know, there are thousands, maybe even tens of thousands of emerging contaminants. One thing that we've done in our lab is try to prioritize the classes that we think are most relevant to kind of real toxicological outcomes. You know, antibiotics, this is a huge public health threat. You know, this is probably the last century where antibiotics are going to work because we're developing resistance so fast. And so what do we do and how can we slow that down a little bit by doing better wastewater treatment or maybe even reducing, you know, antibiotic use? We overprescribe antibiotics right now. We misuse antibiotics. We can definitely cut that down without greatly affecting our ability to treat infections. The UV filters, this is one that kind of seems innocuous. Like we put them on our body in pretty large concentrations. You know, you're in Florida right now, probably you're wearing some sunscreen. But you know, there is evidence that they're toxic to corals at very low concentrations, and corals are super critical for marine ecosystems. And so they're already facing a lot of stress from climate change. If we put chemical stressors on top of that, that can lead to kind of catastrophic consequences. So we've tried to put like our emphasis on these classes that are either seeing real toxicological threats or real regulatory kind of things coming down the pipeline, like is the case for UV filters and PFAS right now. But can you define TSCA for me? I don't know what that is.
The Toxic Substance Control Act, right? So kind of getting the pollution prevention. And not that I don't want to follow up on that one, but I am also sensitive to time. So
got it.
You'll see some in the Q&A, and folks, I do encourage folks to follow up with Dr. Blaney directly. Lee, fantastic, great presentation. Thank you so much. We appreciate it. All right.
Thank you.
Thank you. All right, folks, our next presentation is by Dillon Hoffmann. He's a special project manager, engineering manager at Hoffmann Group, LLC. The title is a subsea oil spill response solution for a toppled platform that has been leaking into the Gulf of Mexico since 2004. The brief synopsis. In 2004, during Hurricane Ivan, an oil platform toppled into the Gulf of Mexico, resulting in an ongoing leak of oil and gas into the Gulf waters. This presentation will outline the design, fabrication, installation, and maintenance of a first-of-its-kind rapid response solution system that's captured and recycled over 1.25 million gallons of crude oil that would have otherwise spilled into the Gulf of Mexico. Dillon, the stage is yours.
Thanks, Dan. I appreciate it. I want to thank the AAEES for giving us the opportunity to talk on this project. So a little bit of background on the oil and gas industry in the Gulf of Mexico. There's about 2,000 offshore structures, a little over 13,000 miles of active oil and gas pipelines, and about 1.7 million barrels of oil are produced a day in the Gulf of Mexico. The oil and gas industry for now is a very important part of our life, at least down here in the South and even across the country. So sometimes things do go wrong with oil and gas, though, unfortunately. So this is an artist's rendition of what we believe happened with the platform during Hurricane Ivan in 2004. So while this is going on, I'll talk to a little bit of site history. There was a responsible party who, after this happened, did their best, put their best foot forward in trying to work through things and get this site patched up the right way. And they were ultimately could not get anything accomplished. So at that point in 2018, the United States Coast Guard put out an RFQ to a bunch of contractors throughout the, I think we can go forward now, throughout the country, and Hoffmann Group was selected as the contractor. And what our task was to install a subsea collection system to mitigate surface sheening from the oil leak. What you see here is the platform before the collapse on the left and the platform after the collapse on the right. Those three red dots, or the two in particular next to oil plume locations, are where we were told the oil leak was emanating from the seafloor. Upon award of the contract, we immediately went into survey mode and wanted to trust but verify all the information given to us by the U.S. government. What we found were those four black dots labeled as plumes are where the oil and gas was emanating from the seafloor in relation to the jacket. And what that enabled us to do was develop a system that we were able to cantilever and build off the jacket that is above the seafloor. It does not rest on the seafloor to collect the oil. So what you see here is the system as its whole. oil, gas, and water flow into the white square down at the bottom. That's what we call the dome. Flows into a patented oil, gas, and water separator, and then flows into the tubes that are laying across the top of the platform. Those are our oil storage containers. So this site is 460 feet below the sea level. So we needed to utilize what's called saturation diving, which is a really complex, specialized form of diving, which requires divers to be under pressure for up to a month at a time. And in this case, we had multiple sets of divers that went in and got pressurized for a month at a time. They were installing some hoses on the tanks there. And this is their sat bell is what we call it. It's basically their elevator from the ship where they're working, and it brings them down to site and keeps them under pressure the entire time. These guys were integral to a part of our success on this project, and it was not possible without them. So big thanks to the divers that worked on this project, and we appreciate all their hard work. That's the same one. I think we can probably forward through that again. But with the sat diving, it's a necessary evil, if I'll put it that way. It's highly complex. It's quite dangerous for the divers. So we try to avoid using divers when possible, but sometimes it is necessary. So that's what we did on this site, and all those guys worked out well. No safety incidents, and everything went overboard one time. So this is our before and after results of the echoscope. You see on the first picture that keeps cycling through is 4 plumes emanating from the seafloor. It looks like an underwater volcano, as it's been described by some. And once we installed the system, that underwater volcano was captured and went into our dome, that then went through the filtration system and captured. So when we were first handed information over from the government, there was concern that hydrants would be a problem on the site, and hydrants would be basically icicles or ice crystals that'll form on the oil or any of the pipes down there as things roll through. We performed an analysis and indicated that the hydrants would not form on site, so we were able to move forward with our design. So one thing to keep in mind when you're designing to use a mangled and beat up platform is that you need to be able to make what's not straight, and be able to articulate different things in different directions. In order to do that, we designed these 3D articulating clamps that moved in the X, Y, and Z direction that attached to our platform and different components of the system. These are one of a kind and really, really pretty interesting to use. So one of the meat and potatoes, or the heart of our system, is the Subsea separator. It's a patented separator that separates oil, gas, and water. Oil, gas, and water flow into the separator. Water will fall out of the bottom. Gas will be vented off of the side into the water column, and our crude oil will be sent over to the storage containers that get offloaded on a monthly basis. Our system has a capacity of about 1,450 barrels that we offload monthly. This is an image of some of our system components that we utilize the waterways of South Louisiana to move around because they were enormous. Just for size reference, there's 13 guys on this barge. So even those clamps that look really small in this picture, they're the size of a Volkswagen Beetle. They're huge. So that's how we moved everything around. And on a project of this scale and complexity and health and safety concerns, we tested everything from extremely small scale testing, even in the owner of our company's backyard pool, which his wife was thrilled about, to have some oil in her pool. But luckily our technology worked on the first go and everything was successful. We tested from really small scale tanks all the way up to large scale tanks, where we were actually able to launch ROVs in the tanks and ensure that our separators are working. So that led us to the next piece. We know the science works. We know the technology works. Well, how does all this stuff fit together? So keep in mind, we installed and built and fabricated this system in a 5-month period. So one sole fabricator was not responsible for doing all this. We had 6 different fabricators. So you have to worry about different things coming from different fabricators and building and fitting together. And that was part of our really large scale QA, QC, and ITP process, inspection test plan, where we made sure every single nut, screw, and bolt of the system worked in conjunction with each other. It required a lot of time, energy, and effort, and all parts of the ITP were signed off on by Cuvion Group, the engineer of record, and the captain of the Coast Guard for our region. So when we first arrived on site, it was really a grim and nasty place. You could smell oil on the surface. You could see it on the surface. Any equipment that we put in the water with cameras, you could see fish swimming through it. It was really a nasty, gross place that it didn't feel like humans or any life should be around it. So it was our goal to make sure that that got patched up immediately. So after our system was installed, this is what the site looked like and what it still remains to look like today. We've restored it back to good working order. The system is over 97% effective. There is on occasion some oil that does leak out. We don't believe that oil is coming from the system, but other areas on the site, as there was a mudslide out there and a tragic event. But one question that we do get a lot is what happens to the oil after we collect it? Well, we ship that oil to those red and white containers that you see on the dock side from the vessel. And we process that oil over about a week's period and send it off to sale. So right now you could be using a product that utilizes oil that we captured from a spill in the Gulf of Mexico. To date, this number is updated and we have a regular tally that gets updated weekly. We're at 1.3 million gallons of oil collected. So in the eyes of the United States Coast Guard, 100,000 gallons is a major oil spill. At this point, we've collected 13 major oil spills from this site. And I just want to thank everybody that's been a part of the Kuvion team. Everyone that's worked on this job, there's been many people, and thanks to everybody in the AAEES for letting us, shed some light on this situation.
Dillon, thanks so much. That was a fantastic presentation. Did it feel like 6 minutes and 40 seconds or much longer?
Felt like 2 minutes.
What they call the elevator pitch, right? Get it in, get it done. So a question that came in. So what's like the true efficiency or the measured efficiency there for capture on the sea floor? Is it like 100%, or is it just like a combination of like the wind and the assimilative capacity takes care of what's left? So that's kind of one question. Second one, how about storms? How about, other events that are occurring? You talked about landslide, but kind of like what's the life expectancy of this? And then the third one is perhaps if you can speak to a little bit about that interface between, practice engineering and kind of that cutting edge translational or move something from lab to field engineering, because you guys were clearly working in that translational space, right? Backyard pool to out in the Gulf. So if you can speak to those three, so kind of what's the efficiency measured out there? What's really going on the seafloor?
So we do an annual report on efficiency of the system. And the way we measure that is there's three different ways that we measure surface sheening or observed surface sheening. We have drone overflights. We have overflights from the Coast Guard, which is either by a seaplane or a helicopter. And there's also NESDIS satellites that are operated by NOAA. And what we do is we had a baseline pre-system installation and then a measurement of a time period of 1 year after the system's installation and each year thereafter. And we measure the differences between. So we'll never be able to see that pretty 100 number, but we're approaching the 99 and some decimals. We're at the upper 90%. The last one, and I'm actually working on a current one right now. We're above 97% is what I'm comfortable with saying now, but it's likely quite a bit higher than that as far as efficiency goes.
Congrats. How about storms coming through and other things? What's the life expectancy of this solution? Is it going to be back out there in 3 to 4 years? Is this going to be working for the next 30? What are your thoughts?
So everyone that's worked on this job is native to the Gulf Coast. So hurricanes are not something that we're unfamiliar with. We deal with them every single year, multiple per year. So when we designed the system, we designed for a 100-year storm. As far as wave action down 460 feet, you don't see very much load cycling. So there was some of that in our calculations based on, can the dome lift up and undulate based on wave heights and things of that sort. That was taken into account. But this system is extremely robust and it can work. The original intention was to only work for a few years until a ultimate solution was in place. But due to a bunch of different factors, this system's probably going to be in functionality for another many years, and the system will work for, I'm confident with saying over 10 at this point, probably closer to 20 or 30.
Wow, fantastic. And then how about working in this translational space, right? Because I've seen some videos on this presentation, right? So from the man cave with folks down in a basement and chatting with each other over their desks, to the backyard swimming pool, to full scale dropping a first of its kind over the side of the ship and only getting one chance to do it right. So what's it like working in that translational space? What advice would you give to students who are looking for that? What advice would you give to the academy to help facilitate that? What are your thoughts?
So it's a really interesting project because one of the first things you learn in engineering school is never rush. Make sure you're doing it right the first time. Work the process, do your design, then you might test, then you put it up. We had to do a design build at the same time. This was an emergency response. The Coast Guard said we want it fixed and we want it fixed now. So pretty much we had to find a way to find that gray area of all those rules but still adhere to every single engineering practice. So find your guidelines that you're going to work to. For us, there was a lot of API and BESI standards. Do not give those up at all costs. Make sure you're spreading the wealth between all of your fabricators and subcontractors and getting everybody in the right places at the right time to test everything. As far as bringing things into functionality, test, and test again. Do a small scale test, come up with a few different scenarios where it may or may not function correctly, and put it through the absolute ringer. We've installed the second generation separator on the site. And after all the information we learned from the first one, we still did 4 to 5 different types of tests on the new separator. It's a lot of time and money on the front end to do testing, but for a proper engineering design and implementation, it's really worth every penny.
Fantastic. Dillon, thanks so much. Round of applause. We really appreciate it. Fantastic. And folks, there's some additional Q&A down there, but people can follow up with you offline and be able to talk with you further. So, all right, our next presenter, Dr. Nirupam Aich, as an associate professor at University of Nebraska-Lincoln. Presentation title is Advancing PFAS Treatment Using Nanotechnology and 3D Printing. So talk about translational. This will be great. Brief synopsis of this presentation. PFAS pollution has become a national and a global priority because of their environmental presence and persistence, along with their potential human health hazards. Treatment of PFAS through conventional water treatment processes has been challenging. In this presentation, we'll discuss how nanotechnology and 3D printing are being combined for generating novel point-of-use filters for PFAS treatment and degradation. Nirupam, the stage is yours. Welcome.
Thank you, Dan. Thank you very much. I'm really appreciative of the opportunity given to us to present our work, and I will go ahead and talk about the issues at hand. So PFAS, I'm guessing most of us already know about this, but I will give a brief intro. PFAS, the fluorinated chemicals that has carbon and fluorine together, are long chains, short chain to long chain. They can come up in many different components like Teflons or non-sticky cook pans. They are used everywhere, but they get into the water, drinking water, wastewater, groundwater systems, and they can cause human health consequences for many different diseases. So EPA has come up with proposed drinking water limits for different only 6 PFASs out of the more than 8,000 PFASs now, but they are really digging into having proposed goal of 0 PFASs in water. So there are many different technologies that has come up in many years, but incineration, which is the most effective technology, is very expensive. So adsorption, separation technologies are coming up. But one of the major issues is to degrade PFAS. To break the carbon-fluorine bond in PFAS is most important thing to look at. So now we are trying to use nanomaterials for PFAS treatment. Nanomaterials are useful because they are have high reactive surface area. They can give catalytic activity if you are using metal oxide nanoparticles, but they can also absorb organic contaminants on their surface. So they can give dual purposes. So we are using a carbon metallic nano material like graphene. Here you can see carbon surface which has metal oxide nanoparticles on the top. They can create these metal oxide nanoparticles can have redox active catalysis process that can absorb and degrade PFASs simultaneously. So in our preliminary work, we used these nanomaterials in powder form and tested them with 4 different PFASs, short chain PFASs that are 5 carbon chain PFASs and long chain PFASs, PFOA and PFOS, to see how they can absorb and degrade. And what we have found, long chain PFASs are absorbed more because of their hydrophobicity and can be degraded further than short chain PFASs. But the problem is these nano powders cannot be used for practical application. So we are looking at graphene aerogels or carbon-based aerogels, which are porous macrostructures made of graphene nanomaterials. But you can use them as a filter, or you can use them for adsorption and degradation of contaminants. So we have looked into how to manufacture graphene aerogels. And 3D printing has come up in discussion in our group because 3D printing gives us an ability to manufacture at industrial scale different types of devices. So we have looked into the literature and we are seeing that they are being used in 3D water treatment, printing 3D water treatment devices nowadays. So we started looking into 3D printing. So we had a collaborator who makes 3D graphene-based aerosols using 3D printing. The issue is that when they put it in the water, it breaks out. So we started looking into how we can make graphene-based nanomaterial inks for printing that are viscoelastic enough that they can be printed, but at the same time, they can be stable in water. So we used multiple biopolymers to bind them and to use them with the graphene nanomaterials to bind them and print these small like aerogels. And then we use them to test with different types of contaminants, like different types of dyes, oil, solvent, different types of solvent like toluene, hexane. And we try to look at their absorption capacity for different contaminants. And we also looked at their regeneration and reuse capacity, which was very interesting. We found that they can be used. Then we try to look at if we can use metal on these aerogels, metal, like we used iron, nano zero valent iron on these metal on these aerogels to see if they can degrade different dyes. So we have seen that accelerated degradation using these aerogels is possible. So this is a demonstration of a video that shows we can use these aerogels inside a bottled water filter cap that we designed using 3D printer. So this is kind of a demonstration of using 3D printing for coming up with new water treatment devices. Marisa, can you forward, because I think the video is, yeah. So now we are funded through NSF to look at how we can use the 3D printed nanomaterials and combine it with PFAS treatment to see if we can use that for PFAS treatment in either adsorption or degradation using these 3D printed graphene aerogels like porous structure. So this is kind of the future vision. So we did some preliminary study, and what we looked at is PFOA and PFOS adsorption using different 3D printed aerogels, but with different composition of graphene oxide, because that is the most expensive part. Graphene oxide is the most expensive part. So we try to see. So what we found, the lower amount of geo can be used for PFAS treatment, but there is a long road ahead. We need to look at different things, like if we can tune the aerogel size, shape, porosity, and surface chemistry. Can we understand the mechanism of PFAS interaction with the graphene aerogels, or can we look at PFAS structures and water chemistry, how they impact the treatment? We have multiple other projects also going on. We are looking at nanobioremediation, nanotechnology treatment, followed by biotreatment of PFAS. We have another project from NSF looking at nanocomposite membranes for PFAS degradation, and also from SERDEP program from the Department of Defense to look at nanomaterial-based adsorbents for PFAS treatments. And I will thank my group members who have worked tirelessly to come up with different solutions and preliminary results for different projects that has led us to work in this very interesting area for the future of PFAS treatment using nanomaterials and 3D printing. Thank you, Dan, and thank you, AAES, for the invite.
Nirupam, thank you. That was a fantastic presentation. It's a lot to get done in 6 minutes, 40 seconds, isn't it? You did.
Yeah, I should have better prepared.
No, you did fantastic. It's like I say, you don't want to over prepare this because then it seems rehearsed. You did fantastic, my friend. So one of the questions that I'm wondering about is, how long before these kind of technologies actually get applied in the industrial scale? So I love that you're saying, the graphene, okay, so we can use this as something in the lab, we can kind of, do fundamental studies for understanding what's going on. And then what we needed was some kind of technology to be able to bring it to scale. So we're turning to 3D printing to be able to say, how do we actually industrialize this or bring this to scale? So, similar to other presentations that we've heard, right? There's some emergency nature around like, this PFAS stuff. It's like, we got to get this done because there's like regulations on the books. So where are you at if you had to push down the accelerator and get this out the door, assuming that everything keeps working and it shows that you can deal with PFAS with graphene? How long before you could bring this to an industrial scale?
That is a very good question, because we have been pondering that ourselves too. So so the PFAS treatment we are starting now, but we have started working on this 3D printing approach for 3 years now. So we have a patent pending on that technique, and we are working with a company in New York State, because I was in Buffalo, so we had to have a New York State partner. So we started looking at if we can use it for filtration devices, and they are working with us for last 1 year. So we have found some issues to be applied in larger scale. So we are trying to rectify them. So it's a work in progress, and I would love to say a definite answer, but it's not there yet. So I'm hoping within the next 3 to 4 years, we would be able to bring it to the market if not in very large scale, at least in a smaller scale, we would be. And we have been recently contacted by NASA, Johnson Space Center, Kennedy Space Center, to work with them, because they think aerogel-based treatment technologies are very suitable for their missions in space, because
Very
they're
cool.
lightweight. Yeah. So
no, it makes sense. That makes sense. How about the recycling, right? So you pull it out, right? Now you've got it on this stuff, right? So regeneration, ultimate destruction of PFAS, bring the graphene back into some kind of separation unit. So are you working on that end as well, or mostly just the upfront end?
So I think regeneration, we worked with solvents initially. So for PFAS, methanol is a very good extractor, like solvent extractor. So what we have found, if it's degradation product or just the PFAS itself after adsorption, you can almost take out 100% of that using methanol. So which is cheap relatively. And we are hoping that we can recycle it, but there would be other questions too. How do you dispose them and what to do with that too? So, and there are several aspects, and I think that's why it's interesting to look at different aspects of the problem.
Yeah, this is great. Great. Well, fantastic. Congratulations on a lovely project, and fantastic on your PechaKucha presentation. This is wonderful. Really appreciate having you here. So round of applause. Thank you so much.
Yeah, thank you, Dan. Thank you very much.
All right, our final presentation today. Today we have Dr. Stephanie Bullard. She's a senior engineer to the Assistant Secretary at North Carolina Department of Environmental Quality. The presentation today is entitled Breaking Down the Silos, Multimedia PFAS Work Group. The way for North Carolina Department of Environmental Quality to continue to bring science-based environmental stewardship to North Carolina is to increase the knowledge base and capacity for staff across all divisions and offices in a bottom-up and a top-down approach. Therefore, the goal of this presentation is to highlight how we took a mechanistic approach to assessing and prioritizing PFAS industries across North Carolina and developing a curriculum to go through case studies to identify what is known and not known about an industry and build specific expertise and critical thinking skills for others to be able to dig deeper and more comprehensively into PFAS industries. Dr. Bullard, the stage is yours. Thank you.
Thank you, Dan. So if you're not aware, North Carolina DEQ has been dealing with PFAS since 2017, once we discovered the release of Gen-X from chemours. PFAS is a unique compound. It has the strongest bond that can be made in organic chemistry. And one of the reasons why it's so challenging and so persistent in the environment is the bond strength. So going back to what you might remember learning about in high school or in college is the electronegativity, and the relative differences between carbon and fluorine are why the bond is so strong. But we talk a lot about bond strength, but when we think about the fate and transport of these compounds, we also have to take into account the long chain and the short chain aspects. I'm sure everyone has heard about that since you've been learning about PFAS. And the one thing we can keep in mind is that long chain and short chain will have various fate and transport in the environment. I think we all know by now that PFAS is used broadly across consumer products that I'm sure we all have in our households. It's not just an industrial manufacturing challenge to look at PFAS in the environment, but it can be used in other things. What we're finding is, as Dan, I believe, alluded to earlier, is that PFAS is not just a North Carolina specific challenge, it's across the US and it's also globally. We're finding the presence of PFAS in pristine environments where we would not have any anthropogenic inputs to that environment. What's important today is to note when looking at the life cycle of PFAS, when we look at production, manufacturing, the eventual use, and then once we're done with that product, the waste management aspect of it, each one of those parts of this life cycle deal with emissions, and those are multimedia emissions. When we look at the use and the potential eventual disposal, it gets even more complex when we look at where a specific PFAS containing product can be disposed of and what the potential emissions might be from that waste management aspect. So we're really looking at the air, water, and waste aspects. If you're familiar with permitting a facility from a regulatory agency, and even if your facility that you're working with is across all three of these divisions, most of the time you're just going directly to air, water, or waste to get the respective permits that you need. So to date, the regulatory infrastructure is very siloed, but because PFAS is so widely used and is no longer a single media issue, we're now challenging the way that regulatory agencies have operated by breaking down those silos and having to work together to comprehensively understand that industry. So the first thing that we had to do to prioritize and set up these working groups was to understand the extent and the universe of industries in North Carolina that deal with PFAS. This was done by doing a comprehensive literature review and also looking at the Federal Registry and other EPA reports to bring together how many industries deal with PFAS. One of the things that we found is that when we're looking at industries that either directly deal with it, indirectly produce it, or are suspected to use it, we had approximately 387 different industries based on their NAICS codes that have been identified in the literature. So the next step that we did is we asked each of our divisions, water, waste, and air, to go through their permits and compile a list of those industries that match that NAICS code or that SIC code. And we compiled all of those industries that were across all three of those divisions. And taking into account unique owners, we had 2,800 facilities and 1 in 22 permits that dealt with PFAS. When we're looking just at the breakdown of those facilities, these were the top 5 industries that were across all three of our divisions and dealt with PFAS. These are not based on a mass basis. These are strictly based on the number of facilities across North Carolina. So what we did is we wanted to prioritize which industries we should look at. We got input from the division directors, senior leadership, but also the individuals that are permitting these facilities and inspecting these facilities to determine which industries we should start with for our multimedia working group and to further evaluate. What our goal is to put together a multimedia PFAS working group where we pull others from each of their divisions, bring them together, and have them work together on analyzing a specific industry. We have multiple industries across North Carolina, and the only way that we're able to fully tackle these industries is to build our knowledge base. So we're going to start by working together through that multimedia curriculum where we are going to sit down and start with the facility from just conventional regulated pollutants and work our way into trying to understand where PFAS could be in those various processes and those emissions. Since we need to develop critical thinking and knowledge base specifically for each individual, we're going to put together little mini research projects to have individuals understand where they can find this information, so we can empower them to be able to find that information during the permitting process and the compliance process. We'll come back together, and our goal is to develop a permitting multimedia reference database where for example, permit engineer could input the NAICS code or the industry that they're trying to permit and pull from the information that we generate to have a starting place of understanding where PFAS could be used. This is going to allow us to take one person who has the expertise and the ability to find this information and kind of have that trickle down effect and increase the capacity and the strategic thinking within our organization to know how to handle PFAS across the agency. This is allowing DEQ to go from being reactive with chemours in 2017 to now being proactive and trying to get ahead of either emerging industries like EV batteries and green technology, but also handling existing facilities across North Carolina.
We good?
We're good.
All right, fantastic. I heard some clicking at the end, so I wanted to make sure that I wasn't hopping into Stephanie, fantastic presentation. Thank you so much. It's really fantastic to hear these different points of view. I think one of the things that we've got as a question relative to PFAS and what you're talking about is those places where there's an interface, right? You know, like, okay, so we want to be able to land apply biosolids, and we know wastewater treatment is able to capture a lot of stuff. So then, okay, the PFAS ends up there. We don't want it to be a problem for people with drinking water. So how are you managing it when it almost like it comes in, you know, in a sense, dirtier than when it goes out cleaned up? We certainly think about these with some various compounds in drinking water. We think about the rules for the FDA and the rules for the EPA in terms of drinking water quality. Now we're thinking about wastewater treatment, the rules for drinking water, the rules for solid waste, the rules for what's going on with wastewater treatment. How do you bring those perspectives together when you know industries are looking for not adding cost to their bottom line, but still protecting the environment? So how do you navigate when folks are saying, hey, their problem, not mine? How do you get people to step forward and say, well, you know, actually, I can probably, for the least cost, actually deal with the problem here in my industry. So it's on me, I'll take care of it and I'll bear the cost. How does that play out when you're having those kind of conversations?
Those are definitely a challenge. One of the things we've discovered is even trying to get an industry to tell us if they deal with PFAS, we have to actually broaden out to ask if you deal with a fluorinated compound. And there's some industries that really know their process. And then there's some industries that really don't know if they're dealing with PFAS, and we really have to be educated to walk them through that, which is why we're taking on this multimedia effort. What we have found is that if we are familiar enough with that process in that industry, and we come forward with the question of, we are aware that there might be a fluorinated compound in this electrolyte. Do you deal with a non-fluorinated or fluorinated compound? We then finally get the answers that we need to then be able to assess what we do with that information. From the biosolids perspective, and some of these existing infrastructures that are not producers, they're passive receivers. You know, we're trying to understand what the sources are upstream and try to make the pollutants, the polluters accountable for that. And that's going to be a challenge, because if you talk to any company that says they're an environmental steward, they're usually then going to follow up with, you know, regulated compounds. So with PFAS not being a regulated compound yet, or have MCLs, it's really challenging to get an industry to be proactive and voluntarily deal with these compounds. I think that's something that we're still trying to evaluate. We're still trying to assess and then determine how we can proactively work with these industries to reduce the sources upstream of drinking water facilities.
Perfect. Now, and I can immediately think, I'm thinking like mass balance. I mean, it's the classic environmental engineering and science kind of tools, but I'm imagining there's got to be some additional tools. So, if a student is thinking about this, or somebody's thinking about this as an additional career or a second career or a career pivot or move or something, what skills do people need to be able to work in this space? Because this is probably not the standard, I go out and I set up my spreadsheet and I do some design of some unit operation in a treatment system, right? This is much more in that system space. So what would be additional skills that people would be looking for to be proficient and to have a successful career in the space that you're working in?
I think that's a really great question. I think one of the things that I think about is, I would say most of us, probably pre-2016, 2010, really when we started the studies with 3M and DuPont, no one was really an expert unless you're an organic chemist and really understood how to synthesize these carbon fluorine bonds and compounds. I think the biggest thing that I like to tell students in general is, as a PhD, as a master's student, or even as a bachelor student, having the creativity and the critical thinking and being resourceful and knowing where to find the information, you could bring a lot to the table. And even myself, my background's primarily solid waste, but I've had to delve into the semiconductor industry, the EV battery industry, and just have the ability to go through scientific information, synthesize it, and start thinking about just the conventional processes, ignoring PFAS, and then think about how PFAS behaves, how it partitions, and hypothesize where we could be dealing with PFAS emissions. And then the next step is to really test those theories and have an informed, prioritized sampling plan in place to start evaluating those industries more holistically.
Fantastic. No, I appreciate that. Thank you so much. Round of applause. Really appreciate that, Stephanie. Fantastic. Dr. Bolad, thank you. Well, we have had a fantastic event today. 4 PechaKucha presentations: Lee Blaney, Dillon Hoffmann, Nirupam Aich, and Stephanie Bolad. I don't know about you, but I really learned a lot. I think it's a fantastic format to be able to get a lot of information very quickly. I appreciate those of you that threw some questions in the QA box. I appreciate those of you speakers who took some opportunity to throw some answers in as well. Please remember, participants, always feel free to reach out to speakers directly or to reach out to Academy staff or myself, and we can help put you in touch with speakers. Once again, today's PechaKucha for me was being hosted from the beach down in Florida. Part of what we're doing with the Academy, with the PechaKucha events and things like this, is to be inclusive, to make this a place where folks feel like that they can strike a work-life balance and still be engaged in the Academy where they're at in their career, in their personal and professional life. And so I went ahead and did this moderating remotely on vacation just to show you that there's lots of different ways to get involved with the Academy, and it's an inclusive environment where we welcome a whole bunch of different views under the same tent. So Marissa, I will turn it back over to you so that I can hit the beach.
Thank you so much, Dan. Thank you everyone for all your questions, and thank you to all of our speakers today for sharing your knowledge. If anyone would like to reach out directly to our speakers, feel free to email me and I can put you in touch. We really enjoyed being with you all today. We have several webinars planned in the near future, so you can go to aaees.org/events to check them out and register. And if you're interested in sponsoring an upcoming webinar, you can reach out to me directly. My email is mwaterman@aaees.org. Just a reminder, if you're not yet an AAEES member and you're considering joining the Academy, please email me and we can discuss our membership options. Last but not least, the PDH certificates for this event will be sent out sometime this week. And we'll also be sending out a link to this recording in case you'd like to watch it again. That's all for today. Thank you so much, everyone, and have a great day.